Hello guys, so let us start with the PZX triangle. So what is it, PZX triangle? So I'll be showing you one uh, model to understand this PZX triangle more clearly. So this is a model. Here you can see that I have made it like this. Just a minute. So here you can see that this is the North Pole, then this is the South Pole, then this is West, and this is the East. So this is, assume this is a celestial sphere. So now you can see this is just a sponge ball I have taken, and just to explain you how does the PZX triangle works. So basically now I can be anywhere, the zenith or the observer, I can be anywhere here. So anywhere here, so basically our purpose is to put the zenith in the center. Like whenever we are drawing a diagram, we always have to put a zenith in the center, and based on the location of the zenith, if the zenith, or that means the location of the observer, is let's say north, so this is our equator, WQE. So this is our equator. So let's say if our zenith or the observer is at the north, so let's say if it is here, so I have to keep it center, so I will tilt little towards down. So as you can see, now you can see some part of the celestial sphere which is extra. So how much extra it is? Now from equator I have, let's say if my equator, if let's say if my position is 20 degree north, so I have to put this 20 degree north in the center. So 20 degree north I can see more from beyond the pole. So the moment you take it, the globe little down, you can see that this line becomes curve. If I hold it in the center, it is exactly horizontal, but the moment I tilt this, it becomes a curve. This is what you actually draw in the PZX triangle. So the outline of the ball is nothing but a rational horizon, and rational horizon is nothing but, it's a great circle which is in between the zenith and the nadir. Let's say if the observer is here, so the observer means the zenith, so the nadir will be exactly opposite. So the great circle which is exactly in between the zenith and the nadir, so this portion will be the rational horizon. And other than this, now we have this poles, and then this is the equator, and whenever a heavenly body is passing through it, so because this is a celestial sphere, so it has a path which is for following. So the path depends on the declination of the body. So declination can be either north or either south. This is basically equinoctial of the celestial sphere. So north of this and south of this, that will be the declination of the body. So this is all about somewhat I wanted to show you the how it does look like. So PZX triangle is nothing but, now this is the North Pole, so from pole to the zenith can be anywhere here. So let's say if zenith is on this line, so this is Z, so and the declination of sun is north 20 degrees, so let's say if sun is here, so this is how you can make it like PZX triangle. This is Z, and then this is X, then this angle, this PZX when you draw, so this is exactly how PZX will be looking like. So you have to use this PZX triangle to calculate either the latitude or the declination of the body or whatever it is asked. So let us start with the PZX triangle. So guys, here you can see the same thing which I have shown in the model. So this is PZ. So I'll start explaining you in detail like what is each and every point. So P here is the celestial pole, because this is a celestial sphere, so this is a celestial pole. Z is nothing but observer, or you can tell it as zenith. Then X, this is the X. This is x is nothing but the position of the body. So you can see this dotted line. This is s, xs, xr. This is nothing but xr. I have written r because it is sun is rising from the east and it is going to set in the west. So that is why I have written xs. And when the sun is crossing the observer's meridian, so I have written here as xm. And let's say if my sun's position is here, now WQE is the equinoctial. So if the sun's position is below the equinoctial, that means the declination is south. So here let's say if this is the position and this is the position of the zenith, so this is basically what is called as a PZX triangle. And with the help of this PZX triangle, you can calculate your position of observer or whatever it is asked in the questions. So let us see more. Now this circle, you can see rational horizon. Rational horizon, as I have already explained in the model, it is nothing but a great circle which is separating the zenith and the nadir equally. Other than this, we have a prime vertical and principal vertical circle. Basically vertical circles are nothing but great circles. So the vertical circle which is passing, here you can see WZE. So the east-west vertical circle which is passing through the zenith, that is known as prime vertical circle. And the NZS, that is nothing but, this is, let's suppose this is north pole and south pole which is hidden. So the line which is, or you can say the sphere which is passing through the north and south pole as well as the zenith, so that will be principal vertical circle. Then ZQ is the latitude, this is the equinoctial, and this is the observer. So the distance from Z to Q will be the latitude of the observer. And PX is polar distance. Now for example, here the body is south of equinoctial. So to calculate a polar distance is nothing but a distance from the pole to the body. So here you can see from pole to this equinoctial it will be 90 degree, and 90 degree from here to here it will be nothing but declination of sun. So it will be total 90 degree plus declination of sun. This is how you will calculate the polar distance. Other than this, angle PZX is the azimuth. PZX, so this angle is the azimuth. PZ is the co-latitude. As you know that ZQ is latitude, so the 90 minus the latitude will be the co-latitude, that is nothing but PZ. Other than this, we have ZXR. So this is Z, this is XR. Now any body which is on the horizon, that means either the body is rising or it is setting. So the distance from the Z to this point will be always 90 degrees. So that is why ZXR is given 90 degree. Other than this, angle ZPX. So this angle, to calculate this angle, you can also calculate if you have given if we have given LHA, then you can do 360 minus LHA to calculate this angle, small angle, because LHA is nothing but from observer to body. So this is the observer and the body is here, so it is measured westwardly, so this is way. So total 360 minus this will give you this angle. So this also you have to remember while solving the PZX triangle. So let us start with the LHA, GHA and all. So this LHA, GHA, SHA and RA, this all angles are at angle at pole. So this is the angle, this is the pole. So all angles are from related to this pole only. So LHA, let us revise what are all this. LHA is nothing but from observer to body, it is measured westwardly and it is an angle at the pole. So it is from 0 to 360 degree. GHA is from Greenwich to body, measured westwardly, so it is also 0 to 360. SHA is first point of Aries to star and it is measured westwardly. RA is first point of Aries to star, it is measured eastwardly. Other than this, there is something called as declination. It is nothing but from equinoctial to the body, either north or south, so it is 0 to 90 degree. So this was about some of the basic definitions which I want you to remember before we go to PZX triangle. Other than this, now there are two terms which are used. One is lower celestial meridian, other is upper celestial meridian. So the upper celestial meridian is nothing but the meridian in which the zenith comes, and it is always from P. So from P, now zenith is down, so from P to this point, this is the upper meridian, and from P to this point it is the lower celestial meridian. Let's say if I give names here N and here S, so PS will be my upper celestial meridian because the zenith comes in this meridian. So this is very simple, just remember this. So now let us see how to calculate PZX triangle. So now here I have taken two things. There are two things, either you have an angle 90 degree or you have a side 90 degree. So for these two, you have to first determine by the amount of things which I have given to you in the question. So let's say if an angle is 90 degree, so you have to draw this sphere, you have to draw these lines, and the part which is 90 degree you have to write here, angle B is equal to 90 degree. So if this is the angle, so what are the opposite sides for angle B? So the opposite side will be A and C. So this is angle B and the opposite sides will be like A and C. So these are the sides. So this is how you have to draw this triangle in the exam for calculation purpose. So this is angle B, then the other two sides you have to write here, and then exactly opposite to this angle B you have to write 90 minus side B, and then the remaining will be 90 minus angle C and 90 minus angle A. So this is the format where you have to write. This you have to use when the triangle is a right angle triangle. If the triangle have one of the side as 90 degree, so at this triangle is basically known as a quadrantal triangle. For this you have to do the side, you have to write here 90, then if it is a side then the opposite two will be the angles, and if the side is 90 degree then here you have to write angle Y minus 90. Here you see 90 minus B, here it is Y, angle Y minus 90. So this you have to remember, and this will be the opposite, 90 minus Z side and the 90 minus side X. So this is quite special. So these two are there here, and we have a formula here, two formula, very simple formula, just apply and you have to solve, and it is very simple. So sine of opposite side, so sine of opposite side, so here you can see this is the opposite side and 1 and 2 are the sides. So if you want to calculate this and you have given 1 and 2, then you can use this formula, sine opposite is equal to cos of one side into cos of other side. Other than this, let's say if you have all adjacent sides 1 2 3, let's say, so if you want to find the center one, so sine of 2 will be tan of 1 into tan of 2. So these two formulas you can use based on the things which you know. So this is how you will calculate the PZX triangle. Thank you guys for watching.